Welcome back. For some reason I pressed the wrong button while I was recording and the video began to publish, so we're going to continue. One thing we're going to look at that affects population growth is demographics. So different groups of people, male or female, and in human populations we look at race, experience different growth rates, based on sort of, what they do in the population or their role in the population. To look at an example of this, we're going to look at these building ground squirrels who live in California, and they experience there's a sort of divide between the growth rate between males and females. If you take a look at an early age, the death and growth rate. Let me get the pen out. The death rate of males and females is close. But as males get older, say example, we look at when they're 4, the female death rate is 0.46, and the male death rate is 0.82. Males experience greater death rates as they get older. And so, population ecologists would say, well, why is this? And one of the reasons it's thought is that once males get to about the age of 1 or 2, they leave the family unit. And they go out and look for mates themselves, while as females, they stay with the family unit. And one of the reasons why this is particularly important is that these squirrels, they have this behavior that if they see a predator and they're in the family unit, one of the family members will scream very, very loud. One of the squirrels in the family will scream to alert its family members, that there's a predator, and that will allow the other family members to escape or run and hide. If you're a male and have left the family unit looking for a mate, you don't have that. You don't have a family unit to scream for you, per se, to protect you from predators. So that's one of the reasons why it's thought that males have a greater death rate, because they tend to travel, all by themselves, as opposed to having the protection of a family unit. If we take a look at the this is a survivorship curve, and you'll see this is the squirrel yelling out that there's a predator to protect its family unit. And one thing that's actually interesting is the squirrels will only do this if they're in proximity of their family unit or they're related to them. They're less likely to scream out if they're by themselves or not around their family unit. But if we take a look at this survivorship curve, you'll see that as males get older, this is survivors on this side, the survivorship drops, so there's much less surviving males than females at sort of the same age, especially as the males get older. They start off about even, but as the curve, continues, and the males get older, their survivorship is much less. One other thing we're going to look at is how age structure, which is a demographic, thing that's looked at as well, affects the growth of a population. Here, we have Kenya, and Kenya is experiencing rapid growth. And in general, countries that are exhibiting rapid growth have these bowed out shaped age structure curves. If we take a look at what's on this curve, on this side we have age, and we have bars that represent the number of males and the number of females at that age, or the percentage at least. Populations that are experiencing fast growth have large amounts of people at reproductive age and below reproductive age. That allows, since there's a large amount of people either at reproductive age or below reproductive age, that allows them to experience rapid growth, because these people are about to enter reproductive age. More actually, and then less people are going to be entering the non-reproductive age. Now, if you take a look at the United States is experiencing slow growth. The reason why that is, if you take a look at sort of our people at reproductive age and those that are below reproductive age, it's not as much as Kenya, which is experiencing less growth, but these, especially the amount below reproductive age, is not less than the amount at reproductive age. It's a little bit less, but not a dramatically amount less. So the United States, while not experiencing negative growth, is experiencing slow growth. Then you have a country like Italy, which has zero growth, where the growth is almost decreasing. And if you take a look at their people that are below reproductive age, there's a much less than are at reproductive age. And eventually these people will enter reproductive age, and these people will exit. And this curve will get even more smaller as it goes down here. But the point is, in general, countries that have these bowed out curves where there's a lot of people either at reproductive age or below reproductive age are experiencing rapid growth. Whereas you have these curves that are relatively equal or even have less people at below reproductive age, those countries are experiencing slow growth. The last part of this lesson, which is one of the more important parts of this lesson, here we're going to look at various strategies or survivorship strategies that organisms have adapted or species of organisms have adapted, and there are three main ones. We'll first take a look at the green one. And the green one is that you have a high survival rate early in age. And then, as you get older, that survival rate decreases. And if you take a look at an example of a species that has that survivorship strategy, are humans. Then we have the hydras, which have a constant mortality or death rate throughout the entire sort of life of their lifespan. And we're not going to look much at hydras and that. And the third survivorship strategy is that you have a lot of death early on, very early age, and then once you reach a certain point, the death rate, lowers or decreases. So here, these oysters at an early age is a very, very high death rate, and then as they get older, their death rate decreases. Now, before we look a little closer at sort of the classification of these survivorship curves, there is a massive trade-off between the amount of reproduction and survival. If you take a look at organisms that have large amounts of offspring, that decreases their ability to survive, because at that point they have to go out and find food for that amount of offspring. So in general, the more offspring you have, so the greater the number of offspring, that lowers your chances of survival. And there's a constant trade-off there between number of organisms that a population can give birth to and how that affects their survival rate. We take a look at this in an example of falcons, or species of falcons. So they did a study where they looked at families of falcons, one in which had reduced brood size, where they removed baby falcons from the family, one that had a normal brood size, and then one that had an enlarged brood size, where they added falcons to the family. And what they noticed in terms of the survival rate is that when there was a reduced brood size, the males and females had a greater survival rate. When there was a normal brood size, the survival rate was at an intermediate amount. And then when there was an enlarged brood size, there was a less survival of both the males and females. Now, if you take a look, one thing that's also true is that it looks like there's a greater, decrease of males when the brood size is enlarged. And the reason why that is it's thought that it's the male falcon's job to go out and get food, and if they have to go out and get food for more birds, there's a decreased rate of survival at that point. But again, the point is that there's a trade-off here between the number of offspring you have and their ability to survive. The more offspring you have, the greater the death rate is going to be early on, and the death rate of both the chicks and also the parent birds. Now to the sort of summary of this. There are two main reproductive strategies that species or populations adapt. The first one is K-selected. In K-selected, organisms reproduce late in their life, they have few offspring, and they invest a lot of care in that offspring. An example of a species that does this is us. Monkeys do that as well. If we take a look, go back to those curves, quickly go back to those curves. The green curve here is K-selected. They have few offspring, they reproduce late, but those few offspring survive pretty early in life. And then as they get older, they pass away. But K-selected, again, they have late reproduction, so they reproduce late in life. They don't have that many offspring per birth, and they invest a lot of care in the offspring. Lastly, we have R-selected. Are selected, they have early reproduction, they give many offspring, and they give little prenatal care to that offspring. So insects are example of this. They lay lots of larvae or whatever they give, and then they don't give very little care. Frogs are another example. Females lay eggs, and those eggs hatch and they turn into tadpoles, and the mother frog is very little care to that offspring. Are selected, again, if we go back to that curve, because there's little care given and there's lots of offspring early, they follow the red curve, where there's a great death rate early on because the parents are giving very little care and there's a lot of offspring. And then once they reach a certain age, that death rate decreases. Again, it's important to know the difference, though, between K-selected, and the way I remember this is that the word that starts with K is kin, so that means that sort of they live in a family unit and they invest a lot of care. And the other one is R-selected, where there's very little care given by the parental unit, and they have many offspring, and they reproduce early. So lastly, once again, we must remember that there's this trade-off between the number and size of offspring versus the survivalship of the parent. The greater the number of offspring they have, the less the survivorship of the parent. And then there's that trade-off there. We also must remember R-selected versus K-selected. In R-selected, an example is a dandelion, they grow very quickly and produce large amounts of seeds. Since they produce large amounts of seeds, many of those seeds don't grow into plants, but some of them do. And they have a large amount of offspring. As a revert, K-selected, we have the coconut palm, and the coconut palms produce less seeds. But these seeds, which is almost like the parent in this case, have large amounts of nutrients as opposed to up here, that for the embryo that's growing in the seed, that ensure greater success of the each individual seed's production of an offspring. But again, we have K-selected, which means lots of reproduction early and very little prenatal care. And then we have K-selected, which means reduced amount of reproduction, later reproduction, but greater survivorship early in life, as opposed to R-selected, when we have lots of offspring, but a very, very low survivorship early in life. And then once again here, if we look at these curves, here we have the K-selected curve up here. I can draw a K. There's our K. And then here we have our R-selected curve, with K-selected early on, high survivalship. But then as they get older, the survivalship decreases. Whereas with R-selected, in the early part of their life, since there's so much offspring, we have low survivalship, or very fast decrease in survivalship. And then as they get older, the decrease in survivalship decreases, or there's less death at this point. And that's the difference between K-selected versus R-selected. Alright. Well, I shall see you guys on Wednesday and Tuesday. Well, basically every day this week. Make sure you do the guided questions. Goodbye.